Let me start here. This is the block A or M1. They are natural length. Let me write. Just this is for our easy way to deal with the problem. So when the springs are natural length, okay, let this be the position. Then, but our problem is what? They are in equilibrium. The system is in equilibrium. So at equilibrium, what do you expect? Say, definitely this will be somewhere in this position, and particle M1, let it be this M2. Both the springs will it be compressed at equilibrium. So we are discussing at equilibrium. So let this undergo displacement XA. This one here, this will undergo displacement how much? X2. I think already we have discussed some basics of springs there. I explained how to deal with such numericals here. I'm just sticking on to the basic fundamentals what earlier we have discussed here. Tell me what is X2? X2 is the compression, because this end is ground, no? It is fixed here. So definitely, so what is X2 in the diagram what I indicated? X2 must be can you hear me? Can you hear me clearly?
Yes, sir.
Okay. No, this is about the springs. So displacement of block M2, let it be X2, that one. So and that will be the compression in the spring. Okay, clear this one. And what is X? The displacement of block M1, let it be XA. XA will not be compression. Compression this upper spring should be has to be determined. Whereas X2 is what? Compression the spring. So they are in equilibrium. So what are the forces? As it is in compression, so we'll write it K1 X1. Then spring force, the weight M1G. At this particular point, what is the state of spring? Spring is compressed, no? The spring is compressed. So how the spring force, this should act here, K2 X2. Then the weight, M2G. How K1 X1 should act? K1 X1 should act downward. K1 X1 should act downward here. I think, okay, this will be M2. Already K2 we have written. Let's equate, let's write some equations related to this. K1 X1. Now, what is X1? X1 is what? The compression in the spring. So what is X1 from the diagram? XA minus X2 is what should be the compression in the spring. Both the springs should be compressed. No? They should be compressed. This should also be compressed. So therefore, what is XA? Like a X1 compression. X1 should be XA minus X2. I'm discussing initial, not final. XA my X1 is equal to XA minus X2. This is very important. Write equation 1. Then let's equate K1 X1 for equilibrium of the upper block. K1 X1 equal to, I have not entered into the problem background, I'm clearing it. For the block M2 equilibrium, K2 X2 should be equal to K1 X1 plus M2G. K1 X1 M1G plus M2G. Call equation, this is, yeah, directly call this is 2. This much is there. What is X2? X2 is equal to M1 plus M2 G by K2. Keep it in. So shall I say this is the compression again? And what is X1? X1 equal to M1 G by K, that's the compression. And XA minus X2 is what? Should be the compression in the spring, that one. So now what we are going to do, let's find the increment in gravitational potential G of the system in lifting the block A upwards until the lower spring becomes relaxed. So what was the initial position? This was the natural length, no? This was the natural length. So I'll bring out. You can solve without diagrams also. To make you understand, I'm bringing this set of diagrams. No? It'll be easy for me to explain for you. So this will be, look at the second spring. Look at the second, now it's at natural length. So write it here. It's at natural length. For this to happen, so what I'm going to do, I'm left it. I'll displace it. Okay, till here fine. So I displaced it. Now what is the question that is asked? Find the increment in gravitational potential of system. Is asking increment in gravitational potential of system. Call this is say y. Some displacement we have given. This is m1. Now look at what should be the spring, elongated or compressed it is. Now the spring one, it is elongated, no? So spring force should act here. Then m2g. So this is elongated. I think your problem is over once you can make out this much of background here. For what is the state of this? This will be an equilibrium of m2. For equilibrium of m2, kx naught minus m2g equal to 0. So what is x naught? X naught equal to m2g by k2. Keep it here. So this you call equation 3 or any number will give it. Now let's come for, can we calculate xa? Xa is what? x1 minus x1 plus x2. And do we have x1 plus x2 value? Yes, we know x1 and x2 value. So increase in gravitational potential G delta U. How much of gravitational potential has increased from the second diagram to the third diagram you look at? How much block M1 got shifted? M1 how much it got shifted? M1G XA plus Y. This is symbol, I'll take it Y, no? X naught again you'll think initial one. Let me, okay fine. Now, how much increment in gravitation put to block M1? M1G XA plus Y. What about the M2? M2G into X2. What are the few things are needed? Do we know Y? Yes, I'll substitute. Do we know XA? XA is what I have information here. So you bring it like this. What is XA? X1 plus X2. What is X1? X1 is M1G by K. What is X2? M1 plus M2G by K2. Substitute all this. Equation 3, this 4. So substitute 4 and 3 in the given equation, you'll get the required answer. Put 4 and 3 in 5. I'll write down the answer, cross check the values. Work done by the gravity, this should be equal to m1 plus m2g. Whenever spring comes, better take help of the conditions, take help of the diagrams. It will be much easier. I think nothing to do. If you can draw a suitable diagram, I think you can manage. That's all here. Okay, now